All right, good morning, Honors Integrated 2. What are we doing today? We are doing something called area of a sector. What's a sector? It's a piece of pie. That's what it is. This little blue thing right here, that is a sector, and I need to find the area of that. Turns out it's extremely related to what we were doing yesterday because, as you might imagine, all I really want is a fraction of the area of the entire circle. So if I had the whole circle, that's cool. I don't want the whole circle. All I want is a fraction of it. How am I going to get that fraction? Same way we did yesterday with arc length, or not yesterday, 2 days ago. All right, let me show you. Okay, how about a little review? Review the area formula for a circle, pi r squared. Here I've got myself a circle right here, and the radius is 3. So if I just wanted to find the area of the entire circle, of course, what I would do is I would just take the 3, which is, of course, r, and just plug that into the formula. That's going to be pi times 3 squared, like this. And that's going to give me two answers, if you will. First of all, this is one answer, 9 pi. That doesn't tell us a heck of a lot, that 9 pi, because it doesn't give us a decimal. But this is an answer in terms of pi. You're going to be asked to leave answers today like that. And when it says in terms of pi, you just leave a pi there. Then it'll say, make your answer also into a decimal. So just multiply by 3.14. And so now my second answer, and if I round to the tenths place, is 28.3 inches squared. So that is the area of this circle, and that's fine, right? And the area of the circle is all the area in the whole circle. But now what happens if I don't want all of the area necessarily? Maybe I only want like 90 degrees of that. Well, wouldn't it be true? Oh, by the way, and this would be a sector. What if I just want this sector? How much of that sector? Well, wait a minute. Is it 90 degrees out of the 360? Isn't that 1/4 of the circle? So what's the area of that circle? Well, or that sector? Well, here's what it is. It's going to be 1/4 of that. So the area for the sector, and I'll put a little s for sector, is going to be 1/4 times 28.3, like this. And so 28.3, and I just divide by 4. And if I round, area of the sector is about 7.1 inches squared. Don't forget your units. Inches squared is important because the measure of area is how many little 1 inch square boxes would fit in there. And there's 7.1 of these would fit in there, although they're rounded. So that's it. Now I want you to kind of pay attention to this a little bit and go, well, hey, didn't we do that yesterday or 2 days ago on Tuesday? All you got to do is take the central angle and figure out how many out of 360 that is. What's the fraction out of 360? And then multiply by the area. And you know what that does? That leads us to the formula. I got you. Here it goes. All right, here we go. Area of a sector formula. Here it is, right here. Take a look at it. I'm using an A sub S just to denote that I'm talking about a sector. And look at this part here. What I got, the measure of the arc over 360. That should look really familiar. What is this part right here? This is the fraction. That gives us the fraction of the circle that we're interested in. Do we want half of the circle? 2/5 of the circle? What do we want? And look at this part right here. Isn't that just the area formula? So I'm very hopeful that you can see that this is extremely similar to arc length. The only difference was in arc length, we didn't have pi r squared. In arc length, you might remember we had 2 pi r because arc length is a fraction of the circumference. Area is a fraction of the area. So that's what we're looking for, all right? That's what's up. Let me show you an example real quick, okay? Okay, so here's my example. Find the area of sector AOB. They are going to name it with 3 letters, and that's because you're doing AOB right here, kind of this angle. And so we have the formula. That's pretty simple, right? I'll just denote that A sub S equals the measure of the arc over 360 times pi r squared, like so. Okay, so far so good. Now I will remind you, allow me to remind you that this is the measure of that arc, which is the same as the central angle. So I can easily just substitute that 70 right here, like so. So here's what I'm going to do. The area of the sector is 70 over 360, like so, times, and then pi times r squared. Well, here's my r. It's 8 centimeters, 8 squared, like this. Now I'm going to leave my answer in terms of pi, and I'm also going to just get a decimal. We'll do the decimal first because that's pretty simple. To get a decimal, I'm just going to put all this in my calculator just the way it is, and that makes it pretty easy. I am going to just use 3.14 and not use the pi button. So there's that, like this, and here's what I get. So the area of a sector as far as the decimal goes to the nearest tenth is 39.1 centimeters squared. There's that. But the other question is, how do I get it in terms of pi? Remember, to get it in terms of pi, we simply leave pi in the answer. You do not multiply by 3.14. So what I would do is I'd cancel this out a little bit, and I'll just kind of rewrite this over here. Get rid of the zeros, right? So now I have 7 over 36 times pi times 8 squared is 64 pi. Now, I could try to cross-cancel because this is over 1. Maybe I will do that right there. And what goes into 36 and into 64? Well, 4 goes into both of those. So I could cross this out, make that a 9, and cross that out, make it a 16, like so. And then I would need 16 times 7. So this would be the area of the sector is 112, and I can put that pi right up on top, divided by 9. Can anything else go in there? Nope, that's going to be my answer right there. Oh, centimeters squared. Just as an aside, that pi can either go on top or it can also go on the bottom. You could have written, or not on the bottom, on the side. So you could have written it like this, 112 over 9 pi, like that. So either of these answers would be a good. I prefer the pi up on top, but this is the same because it's over 1 right there. All right, listen, believe it or not, that's all I got for you. That's pretty simple. And you know what? There's good news. This is the very last new material that you have to learn in Honors Integrated 2. And those of you who have been keeping up with your work and you know, coming and putting your attendance in there and participating, not only do I really appreciate you, but you will all be recommended to Honors Integrated 3 next year. Those of you who haven't, and there's only a couple of you, well, you probably aren't watching this, but you may not be getting that recommendation. I know some of you definitely won't be right now, but I appreciate you. Get this last book assignment in. Next week, we're going to study for some finals. What's going to be on the finals? Listen, the truth is, what I need you to be able to do is factor, quadratic formula, complete the square, do some trig. If we can get all that done, then we're good, all right? You guys take care of yourselves. Happy Thursday, and we'll talk to you soon.